Computerized Start is brought to you by my awesome patrons on Patreon, and by your tips and memberships on Ko-fi. These and other channel supporters make my live streams possible. You too can become a channel supporter with tiers starting at just $1. And as always, thank you for all your support, including sharing, chatting, liking, and subscribing. Now roll that famous logo animation! Good afternoon and welcome back to Computerized Start Live! I am your host, Justin D. Morgan, and this is not the Big Bad Bench, and I am not the Big Bad Biologist, but I am swiping his time slot today, because he's not streaming. I think Trina also swiped his time slot too, so I might have a slow start to the stream, because it should say something that I have data sheets printed that we have to do some reverse engineering before I can actually start applying Bodge wires, so you have been forewarned. Alright. Who have I forewarned? We have Dave's Vintage Apple Tech. Good afternoon, Dave. We have Jack68K. Good afternoon, Jack. We have SadMac356. Good afternoon, SadMac. And we have Callan. Hi, Callan. We have Gutbomb. Hi, Gutbomb. Gutbomb is on Trina's stream and in my chat. Jack says, Big Bad Justin. No. I'm pretty sure I'm going to have to mail in my Dremel's license to... Who makes these? Do they even put their company name on them? Oh, I guess Dremel. I guess Dremel makes Dremels. Go figure. I thought someone else owned them these days. I may have to turn in my Dremel's license, because I think the Dremel's part of the problem. And... yeah, it's been a little while since I last looked at this board, and before you think... this looks like a board you've seen on my channel, you actually have not seen this board on my channel. You saw it on Dave's channel. I had a different 386, 486 board on my channel that I ended up having to return to the eBay seller because it didn't work. This one was a board I think I got from Bill Lewis, so I'm going to fix it, or I'm not going to fix it. There was no eBay returning. Yes, Gutbomb, I have your package. It is safely upstairs in its unopened form because I haven't opened it yet. The only thing I opened was my McMaster car order, because when you pay $30 for screws, by golly, you're going to open the package and make sure you got the screws you ordered. And mind you, it wasn't exactly $30. It was like $27 and some change. And like $12 of that was shipping, but still, when you pay almost $30 for 2 boxes of screws, because those are the screws you need, well, yeah, I'm going to open the order. And I haven't yet checked to see if those actually are the screws I needed according to the internet. Jack68K says, these must be excellent screws. Well, they are the screws that are supposedly what Commodore used in the Commodore 64, because I have a Commodore 64 that my friend Bob gave me. You've seen it on the channel. It was missing all the screws, so I can't put it back together. I was missing screws. Yeah, we have I8386. Hi, Jesse. Jesse says, quick, take that 12 p.m. slot. Yes. All right. So let's see here. We have the Ko-fi goal. Links in the description. And I guess without further ado, we will go to table cam so we can take a look at what mess I have made. I did remember to wash my silicon mat because it had little fiberglass bits on it from Tuesday. You'll probably remember Thursday I was using bubble wrap and other things to keep from scratching things. Well, I bothered to wash it like 15 minutes ago. So it's actually still just a little bit wet. But a little bit of water won't hurt anything, and I'm pretty sure I'll spill isopropyl alcohol at some point, which will make it dry faster. Anyways, so what I have done to this board previously, which I think it was on Dave's stream of March 10th, I have removed the keyboard connector because the battery had leaked, so there was corrosion in that area. I have removed the BIOS chip, and I had to peel the label back so that I could figure out, just confirm I had the correct part number for datasheet purposes. And this is a 27C512. It's either an EEPROM or it's a PROM, but it is not an EEPROM because there's no UV window. So it may not be erasable. It may be electrically erasable. I believe it still works. I think I read it out and it seemed like it was working. But I guess we'll see for sure. I'll probably have to read it again. And I have removed a 74 LS245. This was actually mounted below the BIOS chip. So when I go to put that back, I will have to find some sockets that will let me put that chip under the BIOS, but I'll have to solder that chip directly. And then we have the pièce de résistance. Ignore the 386 or the 486 SX33 in it. This is good enough for testing that I actually have the board working because I don't want to sacrifice anything more valuable. If I lose this, well, it's an SX. As Tech Amber put it, SX equals sadness extreme. Well, yeah, you have no math coprocessor, so you're not going to math fast. Jesse says, I have a doozy of a screw story. Anyways, so this is one of those. Yes, this is one of those boards. I know Adrian of Adrian's Digital Basement had a similar board, and he had a bad power supply fry it, which was definitely sad. Well, this one, a battery tried to do its darndest on, then I didn't help with the Dremel, so I'm hoping I can repair it, but this is indeed one of those 386, 486 boards. So you got the 486 that goes in this socket, and if you have a 486DX, it goes in the same socket. Or if you got a 386, well, there's your 386, and then your 487 goes right here. And these are VESA Local Bus slots. So Jack says SX equals sucks. Yeah, almost. I mean, in Intel's defense, stuff wasn't using math coprocessors a lot back then, but that was definitely becoming more and more a thing as the 486 era progressed until when Pentiums came around, math coprocessors were a default feature, and then everything started using math coprocessors, including games. Jesse says, hey now. Yeah, I'm just waiting for Jesse to, like, change his eBay, or his, YouTube account, i8386DX. You know, Jesse, I was talking about the fact that there's no math coprocessor in this, and I'm just reading what people are putting in the chat, so I'm just going to say that SX processors are, sadly excluding certain technologies. There we go. Jesse, you are quite honestly the master of LTE and LTE 286 hard drive conversion technology. Your live stream is near the top of my watch later list. I wasn't able to watch it live, but I quite honestly am going to have to do the same thing. Callan says, aptly put. Yes. So anyways, here is what we are dealing with now. And you're probably thinking, well, this doesn't look too bad, but there is a problem in that I forgot to take photos before I started dorking with the Dremel. So that's why I have some data sheets. We are going to have to try to figure out where some of these pins go, if anywhere, because I think there are a couple that it's not clear where they go, and I would like to confirm that before I solder sockets. Jesse says, I'm still waiting on our Chinese overlords for parts for that hard drive conversion. Yes, when they decide you can have the parts, you'll get them. It's probably about the way to that goes. Oh, I also apparently still have Z80 processors on my bench. Anyways, I am So here's what we've got. So no surprise, we've got some corrosion in the battery area. I believe this is a broken trace, but at least I can... Oh, wait, I may have fixed that one, because that is actually a wire, so I may have actually fixed this. And I think I may have determined these are fine. I thought something had fell off of here, but I have seen pictures of the board where this may actually be not populated, so we may be fine here. But we do have a broken trace here, and I believe it goes to here. And I believe this via is done for, so I'll probably have to put a wire through the via and then on to wherever it goes on the underside of the board. If it goes to the underside, it may actually just go from here to here, because this may be one of the data lines. Now, the other problem is, as you can probably tell, I don't have all the silkscreen here to know... Oh, actually, I believe this is the notch indicator, so I think now, mystery solved, these two have the notches in the same direction. So, but I can confirm I have the pin out, and if they are in the same direction, this will be connected to VCC. If they are in opposite directions, this will be connected to ground. If I'm not lucky at all, this will be a broken trace, and then we'll have to figure out where it went. Possibly by checking this one, which I believe, if the notch is here, this one should be ground, which may be going to ground on an inner layer. Which may, because I think this is one of the pins where I was concerned we may have a problem. So I think this goes to here. We'll do our drawing on our data sheet to confirm. Hopefully that's ground on an inner layer, and I can confirm it's still ground, which would mean this is 5 volts, which would mean I know where the notches are. And then we just have to deal with the bottom side of the board. So again, I was working on this on Dave's stream on March 10th. That's why there are a few wires in place. And it looks like I did apply one of those enameled wires here to fix this broken trace. I think these next 4 are intact. So it's a simple matter of confirming that there wasn't another broken trace under here. Like, these traces we'll have to double check. I think I need to double check that, because I can't tell if that's a break or a just something on the solder mask. Probably double check those. Double check that, because it looks like the via is a little borked. Ah, okay, we've got a square pin. So here's pin 1. So yep, our notch is here on this chip. So therefore, that is ground, and that's going to be on an inner layer, which is why there's no trace there, which is mean that's going to be 5 volts, and that may actually be going to 5 volts on the top side. No, it may be going to 5 volts on an inner layer. So we'll double check continuity. Actually, this board may be in better shape than I thought it was. But I was thinking there was a few more things that I was worried about, like this one here, because it looks like I've lost part of the connection to the via. That one there, because it looks like I've lost part of the connection to the via. And I am kind of worried about that trace there. Which I think luckily I might just be able to get to the via there without removing the oscillator. And then we'll probably just double check a couple of these, which luckily it looks like a lot of these go straight to this chip here. That's fortunate. So I guess without further ado, let's see if I can confirm where these traces go. So what I'm going to do is I've got 2 copies of the data sheets here. So this is the data sheet for this IC, which is a 74LS245. It's a Motorola part that's on the board, but they're all the same. So I pulled the Texas Instruments datasheet because that I was able to get on Texas Instruments website very quickly. They make it easy to find their datasheets. So what I am going to do, I'm going to color code this so that as we double check that things look like they're making sense, it'll be color coded so we'll remember which is which. Okay, so for the completely broken trace, I am going to, so that is going to be pin, I believe, it's 10, 9, 8. So pin 8 is the one that is completely broken. And that is going to be A6. So I'm going to put a red dot there. So I remember that's the one that's completely broken. And then the one next to it and pin 2, I'm going to use a blue dot because those are the ones that the via is, pin 2 and pin 6. Those are the ones that have incomplete vias. And then, and then for VCC and ground, I'm actually just going to go ahead and check those right here, right now. So let's see here. This should be VCC. I got my multimeter in beep mode. And I think 5 volts is like, there we go. It's the pin all the way down here. So yes, that is connected. Oh yeah, we got a good connection to VCC. And then that means this one's going to be ground, and that's one of the middle pins. And yeah, we got a good connection to ground. So those two are totally fine. And there was there one on that IC that was down on the bottom I want to check? No. It looks like on that IC, the only thing was on the top. Let me double check. Oh, we did have one more incomplete via, and that is pin 19. Oh, and that is going to be the OE. And it looks like 15 and 13 are also incomplete vias. So there we go. So for this chip, we have 1 broken trace and 5 vias that I need to double check because the ring is not complete on the top side. That one there I think is complete enough. I'm not worried about it. It looks like it's at least 90+%. And that one looks like 90+%. It's just these ones where it's like half of it or even less is where I want to make sure we still have a connection to the via. Okay, so that is the middle. That's the chip that goes under the BIOS. And what is this chip? It's basically a transceiver chip. It's a bidirectional chip. I suspect if I were to look at what this board is doing, it's probably so that when it's trying to do a write operation, well, actually, it's probably just an output enable so that it can output enable the BIOS chip. It may also be like preventing the system from being able to attempt to write to it. Although, I don't know why it would need to do that, but I guess it could just be why attempt to write to it if you're not writing, because you can't write to the chip anyways, so I don't know. Chip makers do sometimes funny. It could be possible that in some rare circumstance, writing to it with an improper voltage could maybe still, over time, degrade the ROM chip, so maybe it just doesn't let it try to write to the BIOS. probabilities. I mean, it could be possible that if you continuously fed 5 volts into one of those pins, it could do something. So, I don't know. That's just a guess. All right, so let's look at the outer pins of the BIOS and of it. On the top side, okay, that right there is part of the silk screen. So that's not a trace, that's silk screen. Okay, this should be ground, which it is. And this should be VCC, which it is. Okay. This is actually a trace that is running between pins, so that's not actually for the BIOS, but I suspect it could be for the clock. And we do have a connection, so that is not a broken trace there. So we're good there. So let's look at the bottom side of the connections going to the BIOS. And maybe for these, I will just attempt to confirm these with the multimeter. And then we'll get to fixing the transceiver. So I'm looking at this. So the notch would be here. This is going to be pin 1. So let's just maybe go around the board as best as I can. So pin 1 is address line 15, and quite honestly, I don't think there's a problem with... Yep, okay. So that trace just went to, actually... Alright, so address line 14 is probably... Ooh. I found our first broken trace? Certainly not. I should probably pull up a pinout of the ISO slots. Oh, there we go. Actually, you know, I'm not worried about any of these traces, so I'm only going to tone out the ones that I'm a little worried about. Starting with that one that's got a little bit of a broken via. So that's going to be address line. That's VCC. Oh, wait a minute. No, that's 15. Oh, that's 12. I can't read data sheets backwards. 7, 6, 5. So that's going to be address line 5. Oh, no wonder I can't follow these traces. Who thought of this layout for a ROM chip? Okay, that one's fine. We have continuity. The next one that I was worried about was this one here. And that should be data line 4. Which, see, that comes around and goes up here. Oh, wait. Let me just see if we got continuity. Is it that one there? One, two, I think it should be that one right there. Okay, that actually appears to be a break. Well, it's at least a break in the solder mask, that I can tell you. Wait a minute. How about I do this another way? If that's data line 4, then if I can find data line 4 on the ISO slot, we should have... Oh, wait a minute. Here we go. let me just go to that trace there, which goes up and around, comes over here to the keyboard controller. So I think that is going to be that one right there. Yes. Okay, so that is not a break. All right, the next two I was worried about. That's not one of them. It was, ooh, there's that there. Okay, that is a little break in the solder mask. You know, the good thing is, I believe if I did have to bodge any of these signals, the one good thing is, these definitely aren't differential signals. So I don't have to worry about bodge wire length. How's that for at least one good news? Because as you can see, these are just all over the place. So I think this is just some crud on the board. Yeah, that's just crud on the board. All right, so I think all we got are yeah, okay. And let me just double check the last few things here. So I think this here goes here. Yep, because it's that trace there. Because I think it's capacitively coupled to the... In fact, I think it actually goes to the keyboard controller right there. Yep, with a little capacitor in the middle. Okay. And that other trace that I was worried about, that I think it's just some schmoo on the board, is that one. And that goes... to that capacitor, and I think that one goes to the keyboard controller underneath it. Yep, right there. Yeah, this board doesn't look terrible. I may have prematurely given up on it during Dave's stream because of that, and I was probably having trouble getting bell wire, using enameled wires, but I'm going to use the new Bodge wire technology I have called the wire wrapping wire. Now let's see if I actually reconnected that trace, if I can see where in the world it goes. Well, I have no idea where that goes. You know, I am not sure I even fixed that. Oh, I did fix that. Okay. So that actually is not a broken trace. Yeah, this board is actually not too bad, all things considered. So it looks like all I got to do is confirm these 5 partial vias actually do connect still. Because if there's enough of a connection I can solder it, then we're good. So, okay, this one's an output enable, and that goes... Ooh, I don't know where that goes. Looks like it goes... It goes underneath the ISA slot, I can tell that much. Or no, it goes under this resistor pack and down and... Oh! Actually, I think it's this trace here, which then comes down and... Actually, I think it's going to be maybe that pin right there. Or one of its neighbors? No. Okay, I may have to remove this resistor pack because I think that actually might be broken. And I can't tell where that goes. Okay. So, output enable, I believe, is broken. Okay, the next one was data line, output 4, which goes here. Okay, so we still have a connection there. Output, that one's not, let's see, that's going to be output 6. And, yep. And then I want a multimeter that's smart enough to know that I'm still using it because I'm making it beep. Is that too much to ask? Okay, I think the A side here goes to one of these. Yep. The resistor pack, I think, is acting as a pull up or pull down. And let's see here. So if that was address line, data line 2, 3, 4, 5. Oh. Well, I thought they might be in order. Okay. Still have a connection there. So that's the break. So if that one goes there, because that's data line, so that is A8. So, no, that's A8 on the chip. So 8, 7, 6, 5, 4, 3, 2, 1. And then, is that by chance where output enable goes? Or does output enable actually maybe go here? No? Okay. Oh, hey, Will. We have KMac Vintage here. Alright, so I need to remove this resistor pack so that I can try to figure out where this output enable goes, because it looks like that one... So it looks like that one is broken. And this one definitely is broken. But we know where... Oh, sorry. This one's easy because I was able to figure out where A1 to A8 go, excluding A6. So I'm pretty sure A6 goes to the one that had nothing connected to it on that resistor pack. So that one's an easy fix. I need to see where output enable goes. B4 is fine, B6 is fine, A1 is fine, and A5 is fine. So let's get this resistor pack off the board. See if we can figure out where output enable goes, and then we might be, who knows? We might be computing at breakneck speeds. Or I could figure out there's more wrong with this board. Thing is, I don't know if this board works. It had broken traces when I got it. While I wait for Claris to warm up, let's take a look at some of the other features of this board. So this board supports up to 256K of cache, and it looks like we have 128K of cache installed. These do appear to be real cache chips. This board was made by, I think, Wintech or Edom or Wintech. I don't know that they were involved in the fake cache scheme. Anyways, there we go. Got 128K of cache. There's our 386 if we wanted to choose that. And then there's where our 486 would go, or the 387 coprocessor. I believe... Let's see, this is the Opti 82C495 SX chipset. These are actually 2 VESA Local Bus slots. Unlike some 386 boards that it looked like it was VESA Local Bus, but it was definitely not. These actually are VESA Local Bus slots. And our warranty expired in probably 95. It looks like this board was probably built in July of 94. So it looks like we missed this board's 30th birthday. Sorry about that, board. And it looks like QC inspector number 7 passed the board. It has a Jet Key 5.0 fastest keyboard BIOS. I'm not going to test that, because quite honestly, how fast can a keyboard go? And there's our part of our chipset there. Oh yeah, it uses 30-pin SIMs. I think it supports up to 32 megabytes of RAM, at least according to the data sheet of the motherboard, or the manual, or what. Oh, the information I have on the motherboard. I don't think there's a text version of the manual that has survived. The model number is MV008 Rev F. So yes, it has 2 VESA Local Bus slots, 6 16-bit ISA slots, and 2 8-bit ISA slots. And quite honestly, it's kind of a... I mean, the board seems to be well constructed, so I don't know that they were necessarily a high-end motherboard maker, but the build quality does seem to be decent. And I believe, and I think I've got the chips to put another... I find that interesting they call it even and odd banks, but for 128K of cache, you only use bank 0. That might be because when you use 256K of cache, that may very well be the even and the odd bank. It may interleave them, because it looks like I have to put two tag RAMs and then 4 cache RAMs. I do have the chips, so if we get this running, we'll cache it up. All right. Claris is warmed up, so let's get this resistor pack off the board. Okay, good. On the top side of the board, there is a very clear dot on this resistor pack, and as long as I don't scrape the silk screen off there, we've got a box. So, okay, don't think I'll have to worry about getting that back on backwards. All right. I don't remember how amenable this solder was to Claris, but then again, I think when I was working on this board, this was one of the boards I worked on and was unaware that Claris was suffering from a bad heater, which shouldn't be the case now. But the solder might have actually tarnished or corroded from battery juice. So I'm still expecting I may have to freshen this up first. No, actually, I think that is desoldering. Okay, that one's going to require a little bit of new solder because that's going to be a pin that's either connected to 5 volts or ground. So let me just see, what did I do with the big spool of solder I had? That with my new Hacko, it's got a tip holder that doesn't have a solder holder, so oh, there it is. I gotta find a solder holder that's actually, I will just use that because it is hot and not exactly easy to solder around, but there we go. That's either on 5 volts or ground, so I think that's why it's being more stubborn. Alright. Heat up the Hacko. Maybe one of these days I'll figure out how to turn the beep off, because the beep of this Hacko station is quite annoying. I'm pretty sure Dave could probably put his headphones on mute and hear the beep in California. Okay, maybe not quite that loud, but... Yeah, Jack says the Moo Machine is sounding more and more desperate. There we go. Yeah, that's better. Okay, that didn't... That didn't quite get it, so let's do this. If at first you don't succeed, add fresh solder and try again. Also, we'll get rid of that solder bulb before I forget it's there. Now that will probably do it. That should come right out. Oh yeah, that sounded good. Yeah, they do that as they clog too, but in this case it was just not pulling the solder out of that one via. This doesn't do it, I'll pull out the low melt. It just makes a mess. Which is why I sometimes like to try to remove parts another way first. Now let me see if I can... Alright, I think that actually got it, and I think it's desoldered. There we go. And the resistor pack is out. Now let's see if we can trace that one trace that I was having trouble following. Seems like there might be two that... I don't know where that one is going. But let's see here. So it was output enable. So that output enable trace did go under... So it goes under the resistor pack. I think it's that trace that's going right parallel to the ISA... Oh, and then it goes underneath the ISA slot. Ooh, okay. So is output enable... I don't have the pinout of the ISA bus handy, so let me see if it's one of these pins around here. No. Oh. Hold on. I turned the multimeter off. Oh. Oh, there we go. I got it the first try. So, yeah, output enable is going to that signal. So it's apparently on the bus. Yeah. Okay. So that has continuity. So the only thing we need to fix is this trace here. Cool. Callan says, I like to tag team stubborn ground planed holes with both an iron and the Hacko, that or hot air in the Hacko. Yeah, I was trying not to pull out the hot air because it draws my hot air station draws a lot of power on its own. I need to get some more outlets in the basement because I have a refrigerator on this circuit now, so I gotta be careful what I turn on. The soldering iron and desoldering station don't really draw a lot. Besides, my Hacko soldering iron has a sleep mode that's active right now, so it's maintaining heat at a low. Well, it's not maintaining the preset; it's maintaining a lower heat, so not drawing much. Because the refrigerator is like 5 amps, and those stations are probably an amp each. By the time you, maybe a little less, because you gotta look at what they're actually drawing, and yeah, they get hot, but it's a small amount of metal that gets hot, so. Okay, so the way I'm going to fix these is I'm going to use a blue wire on the bottom side of the board. So it is yep. So it is going to be this here. So I'm drawing a line there, so I remember where one side of it is. And then let me confirm I remember which of the. So yep, that goes there, and there should be no connection here. And then there should be a connection here, so we need to go to there. All right, that's our broken trace. So I am going to strip a wire, and I'm going to feed one side in through there, and then I'm hopefully going to get the resistor pack in. With that in, I need to secure that with something so I can feed the resistor pack in from the other side. I'm using this wire wrapping wire because it's a little less fiddly than the bell wire. If you go watch my live stream series on the 386 Champion, you'd see that this wire wrap wire is great stuff. I fixed, I don't know how many broken traces on the 386 Champion with it. Now, granted, that might mean that my Bodge wires are a bit more fragile. I gotta tape them down, but alright, so I'm gonna put the resistor pack back. And then actually let me pull that wire just a little bit so that, well, not that much. So that I got a little bit of wire exposed on the bottom. solder to. There we go. I think I like that right there. All right, now let me see if I can get the resistor pack back in with that wire in the via and hopefully not. Oh. Okay. I thought I had left a little more wire sticking out, but all right, so hopefully I can get this resistor pack in and oh, there we go. I see the wire sticking through now. Because what I wanted to do was bend it over slightly. It's hard to see, and there we go. I kind of wanted to bend it, try to bend it over slightly so that when I put the resistor pack in, there we go. There, you can just see the very edge of it, because that will then let me hopefully insert the resistor pack. And hopefully that wire might still be in the via. Yes, it is. Success. There we go. There's the resistor packs in. The wire is still in the via. I think that resistor pack will actually stay in place. So I'm going to tack that side. I'm going to tack that side. And now I'm going to get our fix. So there's one side of our fix. And now I'm going to put this back in. And there we go. One Bodge wire down. Now, this Bodge wire needs to go on the other side here. So I am going to cut that a little long. And I'll deal with that in a moment. All right, let me set the board aside. I kind of want to clean the legs of this part up. Well, first, let me double check it still works. Because it's a 74 LS 245. Although I may, I think I may just replace this because I think I've got some 240. If I have some 245s, I'm just going to replace it because I have to solder it directly to the board. And that may be better than trying to clean it up and reuse it because it looks decent, but there was battery juice in the area. Oh yeah, you can see, oh yeah, there's the via and the trace that's required fixing. It's still on the chip. Actually, that's not going to go in the tester until I clean it up. Actually, let me just see if I've got a 245 down here. Sometimes it's just easier to replace the part and clean it later. All right, so this tube. All right, none of those can be 245s. Those aren't. Those are. Oh, good. I ordered some PCBs, and I think that's the gal I need for them. Excellent. I don't have to order those. 24 LS194s. All right. Those are 4164s. Those are 573s. 161s. 194s. Gals. You know, maybe those are 126s. Those aren't even LS chips. 157. These are memory chips. More memory chips. 251s. Maybe I'll be cleaning up this part after all. What's the chance I'll find the memory chips I've been looking for a couple weeks while I'm digging for the part that I'm not sure I have? Oh, well, the good news is I theoretically have 245s. The bad news is the cap came off the tube. Oh, the good news is I think the first chip I picked up in the area of the tube is a 245. So maybe I do have some after all. At least one. Oh, I think I might have found another one of the 245s. Let me at least hedge my bets and find another one. Yep, I think that's another one. Okay, I think those are two 245s. Let me pull up the programmer. And someone tagged me on Discord. Yeah, okay. I have boards coming to me from Canada for another project. All right. Let's test these chips that I found that I think say 245. Test's fine. All right, that tests fine. Now let me see if I can get the old chip in the programmer section. Oh. And we're back. I would like to say that as much as I pay Comcast, that is disappointing that they cannot give me 125,000% uptime. I'm of course joking. I don't think there's probably any way Comcast could have 100% uptime 100% of the time. I'm hoping the stream is back. But yeah, I got all of a sudden I saw OBS told me stream disconnected, reconnecting. And it's back, I hope. I'm going to blame Comcast until I figure out otherwise. That is usually the safe party to blame. I mean, it is sometimes YouTube, but It's probably Comcast. Excellent. All right, we are back. All right, let's solder in with beeping devices in stereo. Let's solder in the 74 LS245. So I'm going to solder in the two distant legs. I'm then going to make sure that I have it in the correct. So there we go. The notch is facing that way, along with the dot. Looks like that is an on semiconductor. Jesse says, don't move to Illinois with that anti-Comcast talk. Well, if Comcast would provide fiber internet at a competitive price and with reasonable, actually no caps, because that's just ridiculous. I believe that's something that Comcast is technically incapable of doing. I would consider staying with them. Although at the moment, I will stay with them until the fiber internet is actually in our subdivision. Short term, well, I'm still their customer. Long term, we're supposed to get fiber internet, and well, yeah. As soon as that happens, I will go with the fiber company, because yeah, fiber. All right, it does look like I might have gotten some solder on a few spots of the board where there is broken solder mask. So let me apply some flux, and I'm going to find my solder wick, and I'm just going to at least make sure that there's no shorts. That looks good. I don't think anything's shorted. Actually, it does kind of look like okay, that was close. Okay. Actually, I don't think that is actually shorted. I will double check. It looks like there is a trace that goes right by this. There. And that trace goes around, and that is not shorted. Excellent. So there we go. We've got the IC in. So now, let me see if I can find a 20, I think that is a 28-pin part. Yes, that is a 28-pin part. Let me see if I can find a 28-pin socket. I should have some. Now, whether they're good sockets, I don't know. Those are 24 pins. Those are 32 pins. There we go, 28 pins. Oh, I guess while I modify the socket so I can actually put it in the board, I did order some parts on, I guess, Friday from Jamco. So I ordered 40-pin sockets. that are not garbage. For those that saw me try to put a 40-pin socket on the Commodore 128 board and like fail miserably multiple times, only to get one actually in, put the chip in, have to unseat it for something, and then find out that that socket too was garbage. I ordered some 3M sockets, so yay for name brands. I did order, oh, that order also had sockets for computer. Because they were in the cart. I need to, so there was that. And I'll have to see if, I'm hoping I will have some CIAs soon. Those I'm getting from a member of the community and not eBay. Because I believe both CIAs that are in the Commodore 128 are bad. I haven't decided what to do about the fact that my Commodore 128 is missing a SID. I don't know if I want to bother trying to get a real SID chip, because that can be hit or miss. I may just get a... I'll probably just build a SID kick. I think Gutbomb has a board, because those at least do support paddles and mice. So it won't be quite the 100% authentic SID experience, but, well, I mean, I've got C64s that have working SIDs, so... I'm just kind of hoping that the problem in that C128 is not the PLA. I don't know that anyone has made a aftermarket compatible part yet, so I'd be buying a pulled MOS part. I'm kind of afraid that the problem I'm seeing might actually be the PLA. I think I got them all soldered. Okay. Yeah, they want gold for the keyboards. In fact, they want gold for the keycaps. Because my keyboard, my C128 keyboard, so I have, okay, I don't have a 128D. It's the, like, plastic one. It's missing, like, 3 of the keycaps. Which, I knew that when I bought it. So, the one thing I didn't know when I bought it, though, was that there was no, the seller conveniently forgot to put on the little thing that told the description. He conveniently forgot to mention the SID was missing. I kind of wonder if he expected that anyone buying a Commodore 128 at that price would assume the SID was missing, but I think he should have listed it. That would have been the right thing to do, because the part that I had assumed was, oh, well, he would have mentioned it. He listed everything else wrong with the system. And it's not like the system didn't have any faults. It actually has a fault that I haven't fixed yet. In fact, he tried to figure out what the fault was and gave up, which is why I sold it at, he'd marked it at $60. And that's it. Almost always goes straight into C64 mode with no flashing cursor. Very occasionally, it will go into C128 mode and start printing. It acts like the load key is stuck or something like that. But oh, actually, I was going to read this chip out, the BIOS chip out, and see if it looked like it was any good. So let me go ahead and do that. AM27C512. Actually, that will do fine for reading it. Back. All right, so we have the 0, 1, 2, 3, A, M, 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 I, B, 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 I, O, S, 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 S. Okay, I'll stop that silliness. Yeah, for these 32-bit ROMs, they like repeat the first things 4 times, because I guess AMI assumed that the BIOS could be in 4 separate chips. So therefore, the initial copyright statement that's at the very beginning of the BIOS is repeated 4 times, so that at the very beginning of each of the 4 potential chips, if they actually were using 4 8-bit chips to make 32 bits for the ROM, but I don't think anyone did that on PC in the 386 era, at least it would say AMI copyright at the beginning of all of them. And I guess I could share my screen so you can see what I'm looking at. But anyways, yeah, there's the repeat there. So anyways, that looks good. I think that, it looks like there's a decent readout. It looks like there's random stuff there. The important thing is I'm not seeing any unexplained blocks of FF or 00. And all the text is actually readable. Okay, so there's a bunch of zeros, but that's normal for there to be. But that's at the end before we get to 8,000 hex. So that's actually normal that there'd be zeros there. And there we go. At 8,000 hex, we start up again with more code. And yeah, I think this is a good readout. So that BIOS chip is probably good. So let's scroll down here to the bottom. And yep. Okay, that might actually be normal that there's zeros there. Okay, for the moment, I am going to assume. I can find where I'm. There we go. That is fine. Actually, I just realized. Oh, hey, Tim, welcome. Yeah, Callan says, funny how they leave that stuff off the listing. Well, I bought it at a swap meet. So the seller had taped labels on all their computers to tell the state. And yeah, so it did accurately describe the symptoms, but it didn't mention the SID was missing. In fact, actually, I'm kind of afraid what I might find in my +4. Does it have a SID? If so, I bet its SID is missing too. I haven't opened it up yet. I don't have a power adapter for it. But it just dawned on me I should probably check this board for shorts, because my luck lately with tantalum capacitors has been, oh, you got complacent. I'm going to go pop. Okay. Not a guarantee that the capacitor won't go pop when I power the board up, but there is nothing shorted at the moment. Okay. So we got power. The BIOS chip is in. Oh, I have a new subscriber. Invest it for. All right. Well, that's so cool. So cool that people can be into investing and computing too. All right. I'm trying to find my postcard because reasons. Well, I guess I could at least put some RAM in the system, so I'll borrow that for 1 MB there. I don't know where the postcard is. It's hiding on the bench somewhere. Let's see here. I believe because these sims go in this way that's probably bank 0. Because they usually lay them out so that you can put memory in bank 1 without having to remove from bank 0. Oh, that's not a PC card. I'm in the absence of finding my postcard, which I probably... Oh, wait, that's right. That's right. I put it in the drawer so that I would be able to find it next time I was looking for it. Well, that didn't totally work, but well, at least I did finally remember. Oh, I should probably check the jumpers on this real quick. That's 387 pin 1. Where's 486 pin 1? Because I got the board turned around. All right, let me pull up this board on the retro web. Because I got everything turned around. MV008. Documentation, MTL jumper manual. Okay, so it looks like they've drawn that the notch for the 486 is that way. With the notch in this corner. So hopefully that is correct. I guess since I got the jumpers up, let me double check this real quick. So CMOS memory normal operation is JP1. That should be on 1 and 2, which it is. All right, DRAM. Okay, yeah, we're good on DRAM. Let's see your cache configuration. I'm going to presume the cache jumpers are correct. CPU type configuration for an 80486SX JP11 13 should be open. And let's see, 11 and 13 are, let me guess, clear, very far away from the CPU. Oh, there's JP13, which is open. JP11 is closer to the CPU socket, and it is open. Okay, and JP15 should be 2 and 3 closed. JP15 is... Yes, 2 and 3 are closed. So, JP5 pins 1 and 2, JP6 closed. JP5 is between these JP5 is 1 and 2. Yes, 1 and 2. JP6 should be closed. JP6 is closed. Okay. So that basically sets that I'm using a 486SX and a 486 type processor, and I think I'm going to assume that the rest of the settings are correct since I double checked those. Those are probably the most important. All right. Well, welcome, Invest4. We have people from all over the world, I believe, in the chat. So let's see here. All right, so as soon as I turn on the smart outlet, wait a minute. Oh yeah, spam caller. The way I know that is because I recognize the area code, but not the phone number, and I got a call the other day from the same area code and a different number. So I think I got a spam caller trying to call me from that area. All right, 3, 2, 1. And we have power, or we should have power. No. Hold on. Did I get the wrong plug? No, that's the right plug. Okay. Oh! Okay. Well, there's something shorted on the board. Because the power supply, like, turned on and then turned off. Do I have the CPU in? I bet I got the CPU in wrong. That's most likely what it is. Yeah, short already. Yeah, I know. Ah. All right, let me find the... Okay. So I've unplugged the motherboard power. Actually, you know what I should do? Okay. Let me first check. Let me check actual resistances and not just... All right. So... Oh, we got a short on the 5-volt rail. Okay, so... Oh, that's the common. Okay, so we have a short on the 5-volt and whatever that one is. Let me pull the CPU out, because that would be my first guess that I misread the manual and put the CPU in wrong. Interestingly enough, that is not always detrimental to the CPU. At least, it's like, well, not always. At least not on 386s. I've put in 386s in, like, rotated 180 degrees and realized my problem when it didn't post. And All right. So if I pull the CPU out and the short goes away, then, well, I had the CPU in wrong. Okay. CPU is out. Okay, yeah. Yep. I had the CPU in wrong. Or the CPU is shorted. So I had the CPU in 90 degrees. Now I see the mark on the silk screen where the CPU notch is. That corner. All right, let's see how resilient the 486s are. Is it still shorted? No. Okay. Okay, the short is gone. Could the CPU be damaged? Yeah, it could be. I've got another 486 SX33 that I can press into service. Yeah, hopefully I didn't kill it. I might actually... Did I misread? No, actually... Okay, in my defense, because I couldn't see the silk screen clearly... That is what I was looking at. And quite clearly, that diagram shows the notch for the 486 right there. It should be right there. So I will report to the RetroWeb that I believe the diagram is wrong in the manual and that they may want to add a note to the page that the notch is shown in the wrong place. All right. 3, 2, 1. And no postcodes. Okay. Now, because there is a distinct possibility that this CPU is dead. All right, let me go grab my other SX33. If I can find it, that is. Here it is. All right. Notch. 3, 2, 1. Well, it's still Still not happy. All right, let me double check the rest of the jumpers, check the RAM. I know the RAM works. I ran a memory test on it on another computer. Oh, hold on. Well, that sucks. Okay. But you might be right, because I just realized one of these clips is weird. All right. Yeah, the BIOS chip is in the right way around. The notch goes this way. That I know for sure, because I still had the silk screen to show me. If at first you don't post, apply business models, business sustaining amounts of contact cleaner, and try again. Pretty sure CRC will love me soon, because I'm going to have to buy more cans of contact cleaner soon. That actually went. Okay. There we go. RAM feels like it's in good. Contact cleaner. I'll try another slot for the postcard. Contact cleaner. I would contact clean the BIOS chip, but I just put the socket in, so I'm pretty sure it's clean. All right. 3, 2, 1. All right. I guess let me double check the rest of the jumpers. It's possible that. Okay, those are marked 386 only. Oh, I could, Okay, I've got an idea here. Okay, maybe there's something wrong with 486? Because it goes in a completely separate socket. I know that second 486 works. I was using it last weekend or weekend before last. All right, let me grab a couple 386s. So I've got a DX16, a DX25, and a DX40. Now let me see what this board supports in terms of clock speeds. Okay, it does do 25 megahertz. Okay. So for 25 megahertz, I want to do IO bus speed select, AT clock 2 divided by 4. I think this board was really designed for 33 megahertz or a 40 megahertz 386, but, well, I'll just have to use what I can. So I do need to close JP3, which is that one there. So I'll put a blue jumper on it so I remember that that's one I want to remove if I put a 486 in. So let's see here. JP4L, it doesn't matter. I don't have a monitor in. Okay. So for a 386 JP5, I need pins 2 and 3. All right. And I kind of broke the jumper, but oh, not enough to matter. All right, pins 2 and 3. Okay. JP6 needs to be open. Okay. Now we're in 386 mode. So for 386, Intel and AMD processors, JP17 needs to be open. Let's see, JP17 is open and JP21 is closed. Whereas JP17 is open and JP21 is currently open. So there we go. Closed. JP21 is closed. That is the one at the very end. Yes, it is. All right. That's for Intel AMD. Speed. 25 megahertz. JP18 is closed. JP19 is open. JP18 is... okay, those are by the socket. So JP18 is closed. So I think that should be opposite what it's set to now. Okay. Yep, JP18 is closed, JP19 is open. Okay. So for 386, JP24 needs to be pin 1 and 2, 25, 2 and 3. So 24 and 25. Just set the whether that's that single or double clock. Those are along the edge, so JP24 needs to be pins 1 and 2. JP25 2 and 3. Oh. Well, that could be... oh, no, that was fine. That was correct. Okay. So, VESA CPU type configuration. So, JP16 needs to be closed and 20 needs to be open. 16 and 20. So, 20 is... oh, there they are. So 20 is open and 16 is VESA speed configuration. Okay, that I don't need to set. How? Okay, I'm not worried about the rest of the VESA configurations. Okay, so we now have the board configured for a 386. Well, Dave, it didn't power up with the 486, so I just rejumpered it for a 386. It didn't post, so now we got a 386 DX25. Again, I do see that the notch is here. I can see it in the silk screen. So I just rejumpered it for 386. So anyways, 3, 2, 1. And no. I think it might be. I think it's coming out of reset. No. All right. I think it's oscilloscope time. At least see if I see any signs of activity. All right. While the oscilloscope powers up, let me see if I can find a place to clip the ground lead onto. Fortunately, I don't have a lot of places that I can clip a ground lead to. Well, I guess I'm going to have to clip it to the power supply here and... Okay, that metal is conductive. All right, and now, through the magic of data sheets, let's see if we have any activity on... I was actually thinking maybe I would just check at the BIOS chip. That seems to make the most sense. Oh. And we'll start there with VCC. Oh, that's right. My oscilloscope is on some triggering mode and... Alright, hold please. Alright. Menu. No. Oh, that's not menu. Let's see here. Shift menu. Oh, that's the wrong one. That was shift acquire menu. No, that's not it. No, that's not it. Alright, exit that menu. Shift utility. Oh, no, I don't want that one. How do I get it off of this? I just want to get it off the trigger. Fine. Alright, fine. Be that way. Channel 1. Channel 1. I'm gonna have to pull up the... I just want to go to free running mode. That's fine, whatever. Okay, so address line 14. That one look. Kind of seems like all the address lines might be high. Or it's my oscilloscope mode. I've got to figure out my oscilloscope. Hi, Trino, welcome. I am fighting with my oscilloscope. I just want to turn it off of trigger mode. I turned on trigger mode the other day and I've yet to remember how to turn it off. Alright, Tektronix. TDS 524. Turn off trigger mode. Display a waveform. Add a probe to channel 1 and connect the probe to your signal. Push channel 1 if channel 1 is not already displayed. Yes. Press auto set. Fine. Auto set. Go, go, gadget, go. And it's still in trigger mode. Let me guess, these instructions are not going to tell me how to push the front panel delay button. Oh, that's horizontal delayed. Use fast acquisition. Oh. Oh, my oscilloscope doesn't have that button. Why in the world is this manual telling me... Ah! I can't open manuals while I'm live streaming because I will misread the manual. That was not the manual for my oscilloscope. It has too many zeros in the model number. Well, Tektronix still has the service manual for this thing on their website. That's pretty cool. Thanks, Tektronix. I will gladly download that before you decide to pull it off your website. Alright, we'll save that. But I would like the user manual, please. Did I read the fine manual? Hi, Francois. No, I have... Well, I did read the part of the manual a long time ago. And apparently... I can't remember how to turn off trigger mode. You know, I could just... Alright, let's do this. Okay. Shift status. Oh, no, that's not the one I want. Alright, exit that menu. Shift. Which one is it? It is application? No, that's not it. Shift acquire menu. No, it's not that one. Hold on. I had the menu a moment ago. Shift utility. No, it's not that one. I'm just going to basically reset the oscilloscope. Shift. No, that's not it. Alright. Shift. Is it acquire menu? No. Shift. No. Alright. Shift Alright. Shift. Status. No, that's not. It's not status. Shift. Acquire menu. No, it's not acquire. Shift. Utility. No. Why can I not find the menu? Setup? No, that's not it. It is. Help. That is not helpful. Yeah, that's fine. That's very nice. Go away, help. You're not helpful. Is it? Is it on the trigger menu? Maybe. Type edge. Mode. Is it maybe? Is that maybe it? I don't know. No, it's still triggering. It's got, yeah, we've got 5 volts on the BIOS, but I want to see if we have any activity on the bus. But my oscilloscope is in trigger mode. I want it to be in free running mode. And I can't figure out how to, oh wait, is it in free running mode now? Because it's actually not telling me it's triggered. Maybe I did finally get it to. No. See, all it's telling me is I got, like, at the BIOS chip, it seems like everything's logic level high. But I think it's lying to me. Can I move the trigger point so it's just not in the signal? Well, no. No. No, it's not going to help. Because then it's just not going to show me anything because it's in trigger mode. It's like stuck in trigger mode. It wants to trigger. I don't want it to trigger. Well, actually, no, it's not even triggering mode at all. See? I need it. It's in trigger mode. I need it off of trigger mode. It's in a mode where it wants to do like a one-shot trigger. I need it like completely out of that mode. I don't know how I got it in that mode, which is why I'm having trouble getting it out of that mode. It is getting very frustrating. I like somewhere I'm trying to find the menu setting that basically will let me reset the oscilloscope to factory defaults. Which is annoying, but that's about the only way I know of. I've gotten it into some mode that I cannot figure out how to get it out of. That's the problem. But I don't remember which menu. Okay, that's not the right menu. No, it's not a file utility. No, that's not it. More. No, it's not. That's the math ref. Okay, that's not it. There's some menu that I can't see the legend for. Is it the status menu? No, that's just his configuration. So it looks like I'm in single sequence mode. Acquire. Where's the acquire menu? Maybe I see where the problem is now. All right, the acquire menu is there. Acquisition mode. Run stop button only. I think I might have it out of trigger mode finally. Hey, it looks like it's free running now. There we go. I got it. Now we're in free running mode. I am not seeing... Yeah, I finally got it out of trigger mode. Well, that's unfortunate. There is like no... There's no activity. Okay, I need to look. Okay, there is no activity. I need to find the ISA pin out because I need to see if we have clocks on the system because well, the good thing is I don't think anything's like scorching hot. Okay, so I'm gonna... Okay, so that is IO channel check on the ISA bus. That's active low. Okay. See, that's going to be reset, which is active high. So here's 5 volts. Okay, we do have 5 volts. I'm looking for clocks. Okay, so I think this is oscillator. And well, we have something on the oscillator. Now I do not know why in the world we don't have frequency. Oh, well that's fun. Why is... Oh. There we go. Oh, wrong direction. Why do we not have the... Well, that's fun. It's not telling me the frequency. But that definitely looks like a very nice clock signal. Now, why... Measure frequency. Oh, there we go. 14. Okay, there we go. I think that's the right frequency there. 14 point... Yeah, whatever. Okay. I'm using a probe that has different characteristics, so I'm not surprised the frequency's not as accurate. This is like a... I don't remember what probe this is. It's a... Not the probe I want to use, but it's the only probe I have that really works for this scope. Alright, so if we go to pin 20, I should have a different clock. So that's pin 30. 29, 28, 27, 26, 25, 24, 23, 22, 21, 20. Okay, and that is 6.26 megahertz. So that is going to be The CPU, okay, yep, that's the correct frequency, because I currently have it set to CPU clock divided by 4. So, okay, we have a clock there. Do we have any activity on the data bus? No. That appears to be pretty much no activity. So there's address line 0. Let's see if we have any activity if I power it up. No. No activity at all. Okay, where's the reset line? Reset is pin. Is that pin 2? Is that reset? Yep, I think that's reset. So I think we're out of reset, so that seems right. Sorry, I can't see the chat. I'm sure you all have good suggestions. May need more jumpers. I think I got everything jumpered on this board that could be jumpered. I'm kind of wondering if the fortunately, I don't have any pinouts for the chipset, so I mean, the main chip in the chipset is getting warm. I don't know if there's any data sheets for this chipset, because a lot of them, there just isn't a data sheet out there. Well, there is a data sheet for the $82C206. Let me take a look at the data sheet and see if that's the integrated peripheral controller. So this says the DMA. So it's this small chip. Unfortunately, the data sheet for the main chip isn't available. So let's see, the data sheet that I have for the chip, I'm trying to see what it does to see if it might be what pulls the system out of reset, maybe. So it's got the real-time clock. Oh, okay, I just had an idea. Yeah, the oscilloscope line, I don't have it touched anything. Let me see if we've got a 32 kilohertz signal for the real-time clock. No, that... Okay, I might be onto something here. I may have just discovered a clock that's missing. Alright, which pin of the chipset does that clock go to, if I can tell? Okay. I cannot read this data sheet. I believe this is one of those chips that many companies made compatible parts for, so I'm hoping that if I can find any of these data sheets, I can actually read the signal names on. So it looks like pin 72 is one of the pins that an oscillator goes into. $72. Okay. Oh, that's the wrong chip type. That's if I was looking at the 84-pin PLCC. Okay, so the 100-pin PQFP, which is what this actually is, that same signal is on a less accessible pin, probably. Pin 75. All right, well, that's not as bad. It's at least somewhere near the end. Okay, so pin 80. Pin 80 is a interrupt. I think interrupts go low or active low. 79. I just gotta do the slow. Okay, that's another interrupt. 78 should be VCC. Wait a minute. I'm not totally sure, but I don't think this chip's one of these chips in the chipset has power. I mean, I might be looking at the data sheet wrong. Yeah, this one chip in the chipset doesn't have power. Well, that's weird. Because that's ground. Let me see if I even see signs that we have the clock signal coming to it. Okay, that is like some signal. I don't know what it is without reading the datasheet more. And yeah, I think this chipset might not have power. That would explain. Yeah, I'm pretty sure this chip not having power. Oh, Trina would like to get a desoldering gun, so yeah, if you can help her out, go check out her coffee. Let's help get Trina a desoldering gun. All right. Let me turn this so you can see what I'm doing now. All right. So, what I discovered while probing this chip here, because this is the chip where the real-time clock is, something told me to check the real-time clock oscillator because, well, the battery, that's where the battery oh, wait a minute. I just realized something. Apparently the bodge I did back in March came loose. That could also cause less than desirable operation. Okay, so we have two problems. I thought we had 0 problems, and then we had 1 problem, and now we have 2 problems. All right, looks like I get to pull the blue wire out. So let's see here. That trace. Oh yeah, that does look like a seemingly important trace. Okay, let's see if I can figure out where it's supposed to go. Alright, one problem at a time. Let's first get this bodge fixed. Let me make sure this one is still connected. Okay, that one's still connected. Okay, so that is definitely broken, which is why I put that bodge wire there. So, where does this go? So this wire here, this trace here, the top one, luckily is the top trace, comes down and to there. Okay. Oh, wait a minute. I've done some... I'll put a blue mark there. Actually, I'm not totally sure that is soldered. Or the pin might be bent over. Okay. So. And then this trace goes from here. Okay, so I'm on the trace with the one probe, and I think it goes to... Not there. Is it there? Yep. Okay. So it goes to... I don't know how well that's going to mark near flux. Probably not very well at all. I probably just got flux on my marker. But I think I got a good enough mark. Alright. Well, let's Bodge Revolution. Oh, Trina, I'll catch your live stream later, but did you get your S3 card reflowed? Alright. Oh, Francois, enjoy your barbecue. Barbecues with friends are always fun. Alright, let's see here. Okay, there we go. There's that, and... Oh, there it is. Oh, that. Solder there. Okay, so I think... There we go. I got the bodge wire. Since the edge of the board is actually not a really great place to bodge because you risk getting it caught on things, I decided to kind of go a little more direct route. given the fact that none of these traces are like matched lengths, I don't think it'll affect anything to have a... I mean, this board's not running at a frequency to need differential traces, so, I mean, I think we're fine there. Okay, so I got that trace back. Now, let me see if I can figure out why we don't have power to this chip. I mean, that broken trace might have been the cause. Okay, so what I said, it was pin 75. That should be pin 80, 79, 78, 77, 76, 75. Sure enough. Sure enough, that doesn't seem to... Alright, let me see what pin that VCC is on the other pinout, because... So... Oh, 80... Oh, that should be pin 78 should have power. And... No, it does not. Oh. Hold on, I may have accidentally turned my multimeter into a hold mode. No, we do not have voltage there. Interesting. So I believe that pin, if I'm reading the data sheets right, that pin should be connected to this pad as well. Oh, no. Oh, yeah, actually, that should be connected. Okay, so we've got a connection there. Okay, we got a connection there. Okay, so those two vias appear to be... Trying to figure out which should have a oscilloscope probe or multimeter probe in one of them. I'm trying to figure out where that is on the other side of the board. Oh, wait a minute. Is that... Hold on. I think I might see a potential problem. Oh, no. Having trouble following. Okay, so the chipset chip that seemingly wasn't getting power is somewhere in this vicinity. And one of these vias around here should have 5 volts on it. I thought I saw a potentially broken trace. But that all actually looks pretty good. All right, let me make sure I got... Okay, so that is VCC. Okay. Let me see if I can find the via around here that's VCC. No, it's not one of those. There's like, should be 2 vias close together, and one of them at least is 5 volts. Oh, let me see if I can find these vias on the other side of the board. And then that should help me figure out where I am in relation to things. Oh, here we go. I found this set of vias. Here's our 5 volt line right here. I'm pretty sure that's 5 volts. Ooh, interesting. And I think that might be 5 volts. Or let me check. Is that ground? Maybe that's a ground trace. Ah, that's ground. Okay. Oh, maybe that's... Okay, I think I just found the via I was looking for. Ah, okay. So that's the ground. This is the 5 volt that should be feeding that chip with 5 volts. And it's not connected to 5 volts. I think there might be another broken trace somewhere. Or a break in an inner layer 1. Oh, that could be nasty. I mean, I am pretty sure that is supposed to have 5 volts on it. Yeah, that is supposed to have 5 volts on it. I am almost tempted to just like jump that to... I think there's a break in... All right. I'm going to look at this area very closely. Interestingly enough, we have a connection here. So that's connected. That's 5 volts. Okay, here's what I should probably do. I should probably power the board up again. And maybe I should measure voltage at that via and that via. Because I have a feeling we're not going to have voltage there or there. Means I kind of wonder if there's another. I mean, it wouldn't surprise me if there's a 5-volt break somewhere. Okay. Yep, that's probably what I need to do. So we'll power the board up and we'll check voltages at both those spots. And if we don't have 5 volts there, I'll jump to a 5-volt place. Unfortunately, there could be things that don't get powered up that I won't know to jump to. I'm also going to see if I can anyway see what LEDs turn on the postcard for other voltage rails. So anyways, we'll turn this on and move the power cord so I can flip that up. So we have, oh, I can't read the silk screen. Okay, so we have 12 volt, negative 12 volt. But we don't have 3.3 volts, which I expected. Okay. All right, let me check those two vias. So I'll stick my negative here in the common. And let's see here. One of them is that via right there. And there is no voltage there. And the other one is that one there. Yeah, I got no 5 volts there. Which leads me to wonder, where else might I not have 5 volts? I'm pretty sure the processor's getting 5 volts. And this chip is getting warm, so it's getting some power at least. But this chip, I don't know that it's getting voltage. All right, let me see if I can find some other data sheets, like for these SRAMs. Are the SRAMs getting power? Actually, let me just do something else here. Is my power supply even supplying all the voltages? Okay, so I have 5.16 volts. So that's good. And we have negative 5 volts. Okay. And I've got negative 12. That looks good. And I got 12 volts. And I got 5 volts there. And I got 5 volts there. I think one of those is like power supply okay or something. Okay, so I got all the voltages I expected. Yeah, Scarlet the Four-Eyed Cuda, welcome. Is there voltage to the cache RAM? Yeah, it's actually what I was going to start checking in that area of the board. I don't know what pin VCC is on those, so let me see. It's a W24 W2465. Okay, that is... Found that data sheet. Now I'm looking at the data sheet in... Okay, so... Alright, it looks like VDD is this pin here. And I do have 5 volts there. And I'm wondering if the corner pin on these is also... Yep. So I have 5 volts at the SRAMs. I've got 5 volts at this bus transceiver. Yep, 5 volts there, 5 volts there. Five volts there. Let me look up the datasheet for a keyboard controller. I8042 datasheet. I know that's not exactly what that is, but it's going to have voltage in the same place as the original Intel part. So let's see, VCC is pin 40 of the keyboard controller. Yeah, that should still be correct. So, let's zoom out so you can kind of see what I'm doing. So pin 40 should be VCC, and we have, yep, we got 5 volts there. Excellent. All right, let me double check that we have 5 volts on the ISA bus. We do. Okay, we have 5 volts there. Let me check the SIM sockets. Pin 1 and pin 30. Oh, cool. So actually, that's cool. So apparently on the 30-pin SIM sockets, the outer 2 pins are VCC. Okay, well that makes it easy to check. Okay, we've got 5 volts on that side. And we got 5 volts on that side. So we do have 5 volts on the SIMs. Whoops. I accidentally touched something with the multimeter probe. So the power supply went to shutdown mode. Fortunately, that was a recoverable fault. I will continue. So we got 5 volts there. I'm pretty sure we got 5 volts going that way. That's probably a pull down. Huh. It's like maybe that chip is the only thing that doesn't have power? Actually, let me check the BIOS chip. Does the BIOS chip have power? Actually, I think I already checked it. Yes, the BIOS has power. Does this chip here have power? Yes, it looks like we got power there. All right. It looks like gut bomb, the chip would have to run at 5 volts. It's got to. It's a 486 chipset. I'm pretty sure it's 5 volts. Because AT power supplies don't deliver 3.3 volts. And there's no 3.3 volt regulator on the board. Therefore, I could be jumping to conclusion prematurely, but I'll humor everyone and also just double check the data sheet. But I'm pretty sure it's 5 volts because, yep, the data sheet for that chip does say power supply 5 volts. So, yeah, it is a 5 volt chip. So yeah, it looks like we've got somehow in the middle of the board we have like two chips that like don't have 5 volts. Which is kind of weird. It almost implies there's a broken trace somewhere on the bottom side of the board. I mean, I could just simply bodge up 5 volts to another point where I know we've got 5 volts, and that would probably fix it. Because it seems like everywhere else has 5 volts except that one spot. Which almost tells me there's like a... Well, hold on. Let me very carefully, because I'm running low on isopropyl alcohol. There are a few spots on the board. Let me... Oh, this board, invest it for, this board doesn't support 3.3 volt CPUs. It's before those. So if you wanted to use a 3.3 volt CPU, you'd have to have an adapter board. Yeah, this is like an early 486 board. Hey, no problem. We all learn. Yeah, some of the very early 486 boards came out before Intel said, oh, by the way, we're going to have lower voltage CPUs now. There's just a few places I want to double check that there's not a break. And basically, I'm just finding there's a couple places where I think it's just some schmoo that's on the bottom of the board that's making it look like the trace is broken. I kind of just have a feeling that I mean, there could be a cold solder joint somewhere. It is a multi-layer board, and maybe some damage in the part of the board at the top broke the 5 volt trace that runs down to that chip. So I guess what I'm going to do is just I don't know how much power that chip draws, so hopefully 30 gauge wire will be fine, but I'm going to very carefully and this might be where I'll just bodge both of these vias. All right, there's the one right there. There's where 5 volts should be, and it's not. I'm just confirming that I got the wire going through that I see the wire on the top side of the board sticking out of that via, and I'm pretty sure I do. In fact, actually, I think what I'll do, just to make sure I'm actually soldering the right thing, I will solder it from the top side of the board. I think for this, Need a dab of solder. These two vias are connected inside the board still, so I'm not sure why they don't have voltage, but okay, and then fortunately, I'm out of, like, anything safe to etch the... What I'm hoping to do is get enough solder down into the via so that I'm soldering it in the via. Okay, looks like I did manage to solder that. So now I gotta find... Oh, I am going to... Just because we're on the bottom side of the board and I don't want to yank that out, I will leave a little bit of that tape there. And there we go. Now, let me see if I can find a convenient spot close by to grab 5 volts from. Somewhere that I know has to be 5 volts. I mean, I could grab it from... Oh, here we go. That might actually be a good spot. So that via's there. Why don't I grab it from... here? Because I know this chip is getting power. So why don't I grab power from that chip? So that would actually be going to here. No, here. No, that's actually, that'd be... Yeah, that'd be right. Yeah, this one closer to me is actually pin 20. Yeah, right there. Because I know that chip is getting 5 volts. So no need to get fancy as to where to get 5 volts from. Just get it from there. And confirmed. That is the correct pin. It is also fairly short. Although, in case I want to put this in a case, I'm going to run this wire. Tactically, I'm going to run it there to keep it far enough away from the standoff. Actually, I'll probably do it right like that. Keep it nice and long. That way I don't have to worry about pinching it on a standoff. May never figure out why the 5 volts is not present here. Okay, let me do this. Let me add a little bit of solder to that pin so I have enough to tack with. Now, I should be able to Yes, if anyone's wondering, the wire does get hot, but it's like a small wire, so like the surface area for it to get hot on is small because it's a small wire. I still probably wouldn't want to keep my finger there for too long, but there we go. So I think now, if I measure between 5 volts and that via, we should now have 5 volts there. Place your bet in the chats. Or chat. I guess there is only one chat. Unless you all are like in some side chat talking about this board. Like, I think he's going to blow it up or something like that. All right. Will it? Actually, you know, that is kind of maybe a complete sentence. Will it? Jack says, yes, the second gossip chat. All right. 3, 2, 1. Go. Well, that, did I, oh, okay. Well, that's, acting like I have a short on the board. Oh, what's the chance that chipset might be shorted? What's the chance that I actually maybe got the wrong pin? Yeah, there's a short on the board now. I sure thought that that's 5 volts. Yep. Did I get the wrong pin? No. All right. Well, let me okay. Well, unfortunately, if there's all right, I want to remove this wire. Okay. So this is connected to 5 volts, correct? Yes, it is. That is ground. So is my short to ground gone now? Yes, it is. All right. Well, unfortunately, I suspect I know what happened to this board. I think this chip is internally shorted. And I bet it burned out the 5 volt trace in the inner layer because I bet that chip is shorted. So when I reconnected 5 volts to it, it's shorted. Scarlett says, hit it with a hammer. Now, we might not be totally in trouble here. Part search time. No, I don't think a reflow is going to do it because I think the chip is not. The chip is making good contact with at least the 5-volt pin. Actually, let me check the, see if I can tell if it's shorted, because we may actually have a shot. Because the one thing is that is a common chip. Let me check the data sheet. Where is the ground on this? So that's where VCC is. I'm going to use the PLCC pads. They're easier to get to. Oh, let me turn this around so that it's facing the same direction as the pinout in the data sheet. That will make it easy for my brain. So that is the 5-volt pad. And ground should be pin 12. Oh, yeah, that's like... Yeah, there's a dead short there. And pin 53. Yeah, I think this chip is shorted. The PLCC pads are connected to the PQFP pads. They're, yeah. This chip is... That's shorted. Now, I said it might not be totally hopeless. Let me go to the scrap pile. And let me see if I have a PLCC version of that chip. Or a PQFP, but I'd rather solder a PLCC. If I've got one, then I'll remove the chip and we'll see if the short goes away. If I don't have one, well, okay, that board might have one. Okay, I have one potential candidate. I was off looking for a replacement chip. Oh, there's my phone. Okay. I'm trying to get it so that I can get the hot air wand out. All right. I don't want to melt the ISA slots, but I think they're far enough away. So, oh, hi, Thomas. How's it behaving? Well, this chip there was no 5 volts going to this chip. None at all. And the 5 volts is, there's an internal plane on the board for 5 volts. So I connected it, and then the board was shorted. I removed my Bodge wire. The short went away, but I confirmed this chip is shorted. So this chip is shorted internally. But it was letting me power the board up before I reconnected 5 volts because it's an internal short to the chip. Yeah, I just need an 82C206. They're all like clones of each other. I've got a board that I think has a donor 82C206, and I think it does. So what we are going to do is we are going to remove this chip. And then I will see if the short is gone. If the short is still present, then it's probably an internal layer problem, and this board is hosed. If it goes away, then we'll see if my candidate number 1 board for donating has this chip on it, or one of its compatible parts. And I just realized that I started putting heat on the board, and I don't know where my tweezers are. That's going to be a problem. Oh, there they are. that's going to require that. And more flux. Having trouble getting it off the board with just hot air. I had applied all the hot air I wanted to, so that was low melt. That was some low melt solder. Actually, I think oh. Hold on, I gotta make sure I'm not frying my monitor from the hot air. This is why I don't like using hot air, because my monitor's not up enough, so the hot air discharge is pointed straight at the monitor. Oh, I make the hugest messes when I use this stuff. Alright, so I think I got the chip off without incident. Unless you look at my bench and all the little piles of low melt solder I got on the bench, but well, that's fine. It's on the bench. Jason, Gutbomb says, I just sold a Zulu Scuzzy on eBay to a guy that lives less than a mile from my house. I would recommend still shipping it. Unless they pick the in-person pickup option. If they paid for shipping, you definitely want to still ship it, even though that makes, like, no sense. And it makes perfect sense with eBay. Ah. Either I got a little solder bridge, or the board is internally shorted. Yep. Yep, that's exactly what you do. They paid for shipping, so you ship it so there's a paper trail. And then if they send you a message saying, oh, I wish I'd known you were that close, well, like, I don't know, you'll think of something. Guess you could just tell them, yeah, I always ship things that you paid for shipping because, yeah. I figured you paid for shipping for a reason. All right. The moment of truth. This board is a goner. Well, I know Bill Lewis the other day on X was commenting how he was surprised that so much of this stuff was surviving. Well, Bill, if you happen to be watching or listening, well, this board that I think you got from one of your various salvages, this one unfortunately has an internal short. So this is unfortunately one of the non-surviving boards. Still, I am quite impressed by the success rate we've been having from these boards you've been picking up. But yeah, this board is internally shorted. There is nothing I can do about that. Yeah, there's nothing I can do. It is internal damage on the board. The best I can do is, Thomas says, cut all the caps off. Yeah. Basically, well, here's what I do. So, my CPU, obviously, I'll put my CPU back in my CPU pile if I can get it off the board. Oh, don't worry. I don't immediately. This board doesn't immediately get put in the bin. And if anyone was wondering how long it would take me today to spill isopropyl alcohol on the bench, well, it has been 0 minutes since I spilled isopropyl alcohol on the bench. Seriously, I think I need to, just I think it's the YouTuber Stez Fix or something like that. He's got a days since melted plastic. Days since spilled isopropyl alcohol. Yeah, I know that. You might as well only put one digit on the thing because I spill it all the time. Okay, I really, really, really got the CPU in there good. Wow. Okay, I pushed that in the socket so good, I can't get the removal tool in. Anyone know how to fix a G3 blue and white power supply? I'm not sure the PC model is pin compatible. No, I'm not fixed one of those. I do know if you have a beige G3, then you actually can use an ATX power supply. You have to change a jumper on the logic board. But the blue and whites, I believe, I don't think they are pin compatible. All right, so I'll remove my CPU. I will remove my RAM. Thomas is asking, are there SMD tantalums on the board? And the answer is no. There are not SMD tantalums on the board. Also, Thomas, the board the board is currently not shorted. The short is in this local area of the board. The moment I connected this chip to 5 volts to restore its 5-volt supply, then the board was shorted. So this is not a and there are no tantalum capacitors in the area of that chip. In fact, the only capacitor in the path of that chip is oh, don't tell me I unflowed that. Is that capacitor shorted? Aw, I think I missed something and I unflowed a chip unnecessarily. No, no. Yes or no? All right, let me remove this capacitor. Oh, you know, I don't think this capacitor is shorted. I think it's just yeah, this capacitor I don't think shorted. It's like a ceramic capacitor. Thomas says there's corrosion short inside. Yeah. Come on. Yeah, I think we've got to. Because the thing is, the board wasn't shorted until I restored the 5-volt connection, and you know, this capacitor's acting like. All right. I will feel very silly if that removed the short. Oh, that's a relief. It's still shorted. That capacitor was. Yeah, we've got a corrosion short inside the board. That is, yeah. Yeah, I'm pretty sure it's. I mean, the only other things in this area are this resistor here, which is not a dead short. It's 32 ohms. Which, I mean, that seems like a low resistance, but I guess I could believe that there's a 32 ohm resistor on the board. I can't read its value. Okay, that capacitor's not shorted. This capacitor here. But that. Oh, that capacitor is. I guess I should remove it too. Just to make sure. But I think it's a ceramic. Yeah, it's shorted as well. But I think it's on the inner layer. Okay. Yep, there's still a short there. That resistor. Well, that resistor seemingly is open, which might be it. Okay, then that capacitor is not shorted. All right, that is all the capacitors in this area of the board. We've got an open resistor, which I have a feeling probably... Okay, that's a 21 ohm resistor. And that's 22 ohms. Yeah. Okay. And then the closest tantalum capacitor is not shorted. Yeah, ceramic caps very rarely short. I removed them just to be sure. Anyways, we got an internal. We got an internal short. I think it's confirmed. So anyways, I will continue what I was doing. So for boards like this, I will, so I took my processor out and my RAM. I'll put those back where I got them from. I will take the cache RAM, and I think I can actually test these in my XG, my T48. I think it actually supports these SRAMs. I won't pull the jumpers off right away, but anyway, so this is a 8K SRAM. Whoop. Where's the window? There's the window. All right, so I think to check these, you go select the IC. We go to SRAM. We go to WinBond, and I think this is a 2465. And we test it. And all right, so we got a good 8K SRAM. So there we go. And then these are 256s, so all right, let me see here. I think that'll work. Yep, all right, so that's a good SRAM. And basically, I'll use these SRAMs to upgrade cache on another motherboard. Assuming I don't destroy the chip pulling it out. I only bent one of the pins, so no big deal. And all right, that one seems to be good. I mean, I don't know that this tester is the be-all, end-all of SRAMs, but at least this will tell me if they're shorted or not. I mean, they shouldn't be shorted, because otherwise I would have seen that. Elsewhere. Oh, these two chips are stuck in the sockets. I am MIA. I should be here. What, is there like audio problem or something? Oh, okay. Just checking. Looks good. All right. All right, that SRAM's good. And this SRAM is... All right. There we go. So it gives me 4 32K SRAMs and an 8K SRAM. And the one other thing I'm going to do, because then this board is going to go into my scrap pile, I am going to pull the BIOS. I'm going to dump it, and then I'm going to see if it's already on the RetroWeb. Because luckily on their Discord they have a little bot. And one of the things you can do with the bot is see if it's already on the RetroWeb. It'll like do a checksum of the BIOS and then compare it against BIOS checksums that are posted. And if this BIOS is not already posted, then I will submit it. So at least... So that in the very least, maybe someone might be able to restore their board. Okay, so let me read it. Oh, gotta turn off ID check. I'm just using a generic chip. There we go. All right, let me save it to downloads. And this is a... What was the name of this board? It is a... why do I keep closing the tab? Fine, I'll type it in. MV008. MV008. I like giving them a name to remind me what it is. So it's an Edom Wintech MV008 Rev F BIOS. Okay. And then I go to the RetroWeb Discord. I go to the ROM check. And I believe the command is exist. So you type in !exist. And we attach the image to the message and... Whoops. Oh. The upload failed. Interesting. Oh, I wonder if I maybe can't upload the file while I'm on streamer mode, or their bot's down. One of the two. Oh, that's interesting. Oh, problem was on my end. All right, so according to this, BIOS upload check, Edom Tech uploaded on the RetroWeb. File hash does not match, multiple string matches. Okay, they may not have this, or... Alright, so it looks like I'm going to upload this because I can't tell from the output whether it's uploaded or not. Oh, that's good to hear, Trina, that your reflow fixed the issue. Excellent. Alright. Anyways, I will... Actually, I guess before I forget, I'll go ahead and... Let me go ahead and just submit this to the Discord here. So, let me see here. New post. This is going to be an improved board. The title... Oh, I always have to copy the template. Let's see here. Improved board template. Okay, let's see here. New post. Okay, so basically I'm just going to try and upload this. So I gotta, whoops, give him the link to the board. This is an EdomTech MV008. So I don't have any new photos. I don't have any new chips attached. BIOS version unknown from a non-working Rev F board. Yep, basically BIOS version unknown from a non-working Rev F board. I could not tell from the exist output if this BIOS was already submitted or not. It may be different than one that is already there. Alright, so give him the link. I gave him the board name. Tell him it's a new BIOS. And since I can't boot the board to see what version it is, this is how we make lemonade from lemons, that at the very least, I can submit a new BIOS, and maybe that will help someone get their board working. So there we go. So at least the BIOS is submitted to the RetroWeb. As for the rest of this board, it is now a parts board. I've got a gal that I might be able to reuse. Hey, let's try something. I wonder if I can read the gal from this. It's probably protected. Wouldn't that be funny if I actually am able to read it? Hey, if this gal reads with my reader, then I'll submit it to the RetroWeb too. How's that? But it's probably protected. So it's a gal 16V8. Why not? We're here. I'm probably going to end the stream soon so I can, eat, because I only ate part of my lunch before streaming, so I know it'll be more like an early dinner at this point, but I kind of would like to maybe eat soon. Alright, so can I read this? Will the gal read? Wait a minute. Hey! That gal was not protected. Life gave you lemons and then made you bring them back. Hey, I actually was able to read that gal out. So that is the gal at U50. which is the only gal on the board. Well, cool. Let me save this gal, and MV008 Rev F gal at U50.jed. And then I saved it somewhere where I didn't want to put it. So let me go figure out where it ended up on the file system. Oh, XG. Oh, it's in the user. All right, there we go. So I will go ahead and let me add this to the, why not? I don't know if gals are something they considered taking, but I'll go ahead. I was able to read the gal at station U50 on the Rev F board and have attached the JED file. There we go. What do you know? Oh, no, the problem in Vesta 4, the board has an internal short. This board is internally shorted in this location. So something happened to this board. Thomas Armstrong said it might be like internal corrosion, or I forget what he called it specifically. Maybe that's the name he gave it. Oh. I mean, I guess, okay, I don't know actually I don't know the mechanism, but anyway, the board has a short. That's why it probably burned out the 5-volt trace internally. So, yeah, I can't repair this board. But I think the BIOS, the hash, I don't think the RetroWeb had this exact BIOS, and it looked like it did read out, so I've submitted this to the RetroWeb. I also was able to read a gal out that was on the board. So I just put this on the submission as well. So I guess if someone has one of these boards and the gal got corrupted, maybe someone out there has an MV008 board and they wish they had the gal. And now they can, oh, I should probably at least mention on the RetroWeb post that it's a gal 16 V8B. Yeah, let me add that. The gal is a gal 16 V8B. So anyways, there we go. I can't fix this board. It probably has some sort of internal corrosion, which, as probably at some point, it possibly burned out the internal trace for the 5-volt to this area, because maybe it corroded while it was in use. And that let the board power up, and I didn't see a short until I reconnected it, and then the board shorted. So I suspect if I let it run long enough, that Bodge wire would have probably gotten very warm. Anyways, so the fate of this board is it's now going to go into my scrap pile, because there is nothing I can do for an internal short. If I need parts for another board, there are some standard logic chips I could steal. Who knows? Maybe someday I might find one of these boards again and there might be a problem with the chips. So I think this chip is fine. I bet this chip is fine. The 74 series logic's probably fine. The SRAMs appear to be fine. There is what looks like a dead bug under that SRAM. That's not fine, but probably not the reason why the board failed. Yeah, I guess even if I got one of these boards and the socket was borked, well, I could 200 some pins later have a socket. I could even swipe the keyboard controller. It's probably fine. But yeah, I was hoping that I would be able to get this board repaired. Alas, it was not to be. But at least now I know this board is now destined for my scrap pile. I guess I'll put this chip with it, because this chip might actually be fine, so. It was fun anyways. I'm glad you had fun. Anyways, I think with this is probably a good time to close the stream out, because I've got YouTube things I watch Saturday afternoon. I know Epictronics usually uploads a video. I think I might have seen that he might have uploaded one, so I kind of like to watch those. I would like to eat the rest of my lunch, even though it's close to dinner now. I would like to eat the rest of it before it gets too late. Anyway, so tomorrow afternoon, I hope to be on Dave's stream. So it probably will be sometime after 2 o'clock. I'll at least hopefully be able to join for a couple hours. Yeah, you're welcome, Gutbomb. I'm glad I could at least entertain you all. And hopefully Trina entertained you all too, in the absence of the Big Bad Biologist. So next Saturday, I believe the Big Bad Biologist probably is streaming, so you won't see me try to swipe the 12 o'clock slot. But who knows? Next time John is not available to stream, if I have a cool board that needs a look at, because my repair pile has a few more on it that I'd like to look at soon. Who knows? I might pull one out for Dave's stream tomorrow. Jeremy occasionally bugs me about it, so maybe I'll pull it out on Dave's stream tomorrow. But anyways, yeah, I'm glad you all could join me for a little afternoon fun. I wish we could have gotten this board working, but I guess I'm in good company, because Adrian has a board similar to this that has VESA Local Bus, and well, his is dead too, so. Oh, Trina, that's fine. I'm glad you were able to get your video card fixed. At least one of us got something fixed today. And I have a few spare parts. Anyways, I'd like to thank all of you all for joining me. I'd like to ask you to smash that like button. That does tell the YouTube algorithm you like these live streams. Don't forget to subscribe and turn on notifications. Invest4 says it's 11 p.m. here. Well, actually, for your time zone, it's a good time for me to stop then. In fact, actually, normally it's quite late where you are when I normally stream. Anyways, yeah, don't forget to subscribe and turn on notifications so that you'll know when I go live with potentially interesting repairs like this. Tuesday, I think I'm going to look at workstations. I have an SGI Octane, and I have a Sun Spark Ultra 10 that I'm going to try to install their various flavor of Unix on. Because quite honestly, I'd like to get IRIX. Well, okay, so I'm going to get booted on the Octane. I don't know if I'll get it installed, because I don't think I have the proper thing to mount the hard drive in the Octane. But I would at least like to get IRIX booted on the Octane. Then I know I'm one step closer. And then the Sadmax says, for the Sun, the bottom comes off. Yes, yeah, yes. Yeah, I figured that out. All the other computer manufacturers, the top of the case comes out, but Sun, I guess, said, well, we got to be different. You're going to remove the bottom of the case. But yeah, so I think I'm going to do that Tuesday, and then Thursday, I might have some different workstations to look at. Maybe not so expensive of workstations. So Thursday might be the workstations we might have actually afforded back in the day. Tuesday is going to be the workstations that we only could have dreamed about buying because they were for businesses. Invested4 says, my latest workstation I built is a Precision 5820. Cool. That Sad Max says, I wish I could have seen In Commander's reaction to finding that one out. Yeah. Anyways, with that. Oh, never seen a sun? Well, oh, you can't quite see it. They're too low to the ground. Well, anyways, even if you can't watch the live stream live, then watch it on replay. And we'll see how far I get on installing the Solaris. Sad Max says, because that's how I learned it. Anyways, with that, I'd like to wish you all a great rest of your day. Hopefully you will check out some other fine YouTube entertainment. Or potentially the weather's nice where you are and you might even be able to go outside. Because I know it's supposed to start raining at some point this afternoon. Here, at least. So, with that, I'd like to wish everyone a great rest of your day. Hope to see you here next time. Take care, and God bless. Computerized Start is brought to you by my awesome patrons on Patreon. And by your tips and memberships on Ko-fi. These and other channel supporters make my live streams possible. You too can become a channel supporter with tiers starting at just $1. Don't forget to smash that like button. And if you've liked what you've seen, subscribe and turn on notifications so that you don't miss the next video or live stream. And as always, thank you for all your support. I hope to see you next time. And until then, take care.